Good morning, and very good morning. How are you guys? How's everything? Well, today morning actually I came across some interesting finding, and I thought, okay, let me put things into perspective and do the testing by myself and share with you guys, right? So, what we are talking? Well, we are talking about having an effect of metering, camera metering over the scene. So, like if we are having this backlit kind of a scenario where you have bright background and you have some dark subjects, so how the metering is going to affect if we do not change any setting, we keep everything the same, we just change the metering. And in order to get this effect of changing the metering of the camera, I put the same lens under the ideal condition, also the same shutter speed. I didn't change any aperture, I didn't change any shutter speed, but what I did change was keeping the ISO into auto. So it means that if I'm going to change the metering, the auto ISO is going to kicks in and we are going to have an effect. Now, while I was doing that and while I was doing this testing, I thought I was actually testing it with D3S, which is 12 megapixel camera. While I was doing it, I thought, okay, let me do something extra. And what it was, well, I thought if we are going to do this with 12 megapixel, let's do it with some high megapixel like D850, which got almost like four times the pixels in compared to D3S. So in this way, we are not going to only observe the camera metering and camera response, but we are also going to see the dynamic range and the recovery of the highlights and shadows if we are going to have this metering effect. So I started with metering, but I put this dynamic range and other stuff into the testing in the comparison of a low megapixel machine versus the high megapixel machine. So now we have 8 images. As you can see, the first 4 images are taken from D3S. Alright, the next 4 images, like from here, they are taken from D850, as you can see. Let me start from the beginning. These are, you can see, D3S, right? So all these 4 images are from D3S. So I'm going to click over here, and these last 4 images are from D850. If I choose this and this, so we are going to have 2 cameras, models and everything, regardless. So this D850, D850, D850 and D850. This one's D3S, D3S, D3S and D3S. Interestingly, the first image I took was at base ISO, that was taken at ISO 200. The metering was matrix metering, so it means that camera is reading the whole scene and getting the exposure. Actually, I was trying to get the exposure 0, so right in the center. So at base ISO with 2.8, I was ending up with 180 of the shutter speed. In D3S, I used 180 millimeter f 2.8 D-tab lens. The same lens when I used on D850, this is where I was at base ISO 2.8 and with 0 exposure. Like when we adjust the metering to 0, I was ending up with 1/48 of the shutter speed. By the way, keep one thing in mind, that these are 4 times the resolution, right? So if I compare D3S with D80, so and I go over here and try to see, as you can see, the D850 is having twice as like resolution. So in order to see the D850, I have to reduce it by 50% in order to match it, or I have to view D3S by 200% to level up with D850 angle of view. So that is, I'm having an issue, but I'll show you guys what I can do. Anyways, so this is D3S. This was taken at matrix metering. The moment I switched to spot metering, and I was trying to do the spot metering at this level of the camera, which was D4S. The moment I switched to spot metering, this happened. So it means that when I switch to spot metering to D4S, this happened, right? And my ISO was jumped from 200 to 12,500. Oh, 1200, 1250, I mean. So it's all blown away. Even I try to correct the exposure, it's not gonna help. Okay, let's go with D850. Same thing. I have to do. That's too much. No, that's fine. Okay, so the moment I switch the metering to wait. Okay, that's too much. Wait. Okay, let's change the metering, and that's what happened. You see, it's all blown away. Okay, now let's compare this with D3S. First, let's check this and check this. Compare. So on the left hand side we have D3S, on the right hand side we have D850. You see, the ISO was all the way cranked up at 1600. This was still at 1200, 1250 with 1/80th of the shutter speed. This was at 1/40th of the shutter speed. Even though the shutter speed over here is increased, but still ISO was decreased. That's the main one of the concept I like to share and clear with you guys, that the pixel on D3S, it's like 4 times bigger than D850. So it was gathering more light. Even though I was cranking up double the shutter speed, still the ISO on D3S is low because the pixel was so big that it doesn't need ISO too much, because the pixel is already big enough to capture all the light. On the other hand, D850, the pixel was so small, like 4 times small, that even you have to reduce the shutter speed half, which is 180 over here, and this is 140. Still you have to pump up the ISO to get the zero exposure, which was in the both cases. So that's one of the clear example, a clear demonstration where you can see why low megapixel are better for low light, right? But don't worry, I'll show you guys another interesting thing. Wait for it. Let's go to develop module. Okay, I'm going to reset everything back. I'm going to reset this as well. Okay, here is what happens. I showed you that if we are increasing the exposure, no, not this. Let's try this. Not this even. But let me show you why D3S is having an advantage over D4S. I'm increasing the exposure. No, let's decrease the exposure. Okay, not this one. Let's try this one. Okay, yeah, that's good. At 1600 ISO. Okay, at this is shutter speed, I am decreasing the exposure by 3 stop. Okay, I decrease the exposure by almost 3 stop. Let's do one thing, -3. Alright, and now I am going to recover the shadows 100%. Look, so clean. I mean, really very clean, right? No visible noise. Alright, okay. I mean, it was overexposed. Sorry, I did something. Yep. So it was overexposed. I reduced the exposure by 3 stop. I recovered the shadows by 100%. Still, I am ending up having a very clean, usable image. Alright, I do the same thing with D3S, which is this one. Okay, let's reset that. This is the image I'm talking about. So I'll do the same exercise. Let's do 211. Yeah. See, I told you it's twice the resolution. So I'm going to decrease the exposure by -3. Alright. I'm going to recover the shadows 100%. Actually, the sensor was not able to recover the details. So I have to reduce the exposure. Let's 2.5, 2 stop. Let's do that. This was taken by -1. So there is a stop difference actually to get this type of exposure on D850 in compared to D3S. So there is a stop difference actually. I have to reduce the exposure by -2 and then recover the shadow 100% to match up the exposure at D850. So over here, D850 have any advantage over D3S. Why? Because D3S was having unconventional sensor, D850 having BSI sensor with superior SNR firmware at -3, and your D3S was -2. So that's a big deal actually. That's a big deal. Even though at -2, D3S image is still quite usable, but when you go and compare with your D850 at -3, still much better usable image than D3S. So over here, the the shadow recovery of D850 is superior. Now, but wait, the funny thing is that's all happening at lower ISOs. When you start increasing the ISO, this is where D3S shines. Let me show you. Let me reset everything. Okay, this is the image of D3S taken at 6400 ISO. Alright, as you can see, it's still quite low shutter speed because it doesn't need that much power. Okay, I'm going to recover the shadows. Oh, nasty. You can see the banding. Okay, quite clear. Let's go 6400. Alright, okay, that's fine. Now I'm going for that D4S, same 100% shadow recovery. It doesn't show any banding, but the details are not much in compared to D3S. Let's compare with, let me compare D3S and then this, compare. Wait. Alright, so on the right hand side we have D850, on the left hand side we have D3S. So as you can see, at 6400 ISO, the details on D3S is still much better than D850. This is all gone. This red marker of the naked grip is all gone. On D3S still retains, and I'm talking about this was taken at matrix metering. See, if I compare, sorry, this part, this area, this button over here is still visible. At D850 is gone. On D3S is still there. Over here, the lens part, the D3S still have the details. D850 all gone. Even the white balance is shifted. This was still kind of a pale. This one is still warm because I set the white balance warm. Even though I am having a banding on D3S, there is no banding on D850, but even by having the banding, D3S is still having the details. Even you see this, that's good. Focus. See this? See this? If we take out the banding out of the equation, D3S is still having an upper hand on D850. Alright, so let's do one thing, reset everything and check this out. DS, now this was taken at D850 at 6400 ISO at matrix metering. The moment I switched to spot metering, this happened. So I want to recover the exposure. So the best way I do this, I press Command U or Control U if you are a Windows user. So that's quickly adjust the exposure by a shortcut. But I don't want to do that. Let's do one thing. I try to do the exposure manually. Okay, -3. Shadow. 100%. Beautiful. D850 is having an upper hand over here because of the superior SNR, right? This is D3S. Okay, I didn't fix the exposure. It's still having the details. Damn. Seriously? 6400 ISO, and this was 6400 ISO. Let's compare. Not compare. Develop. Stop. So I have to reduce the exposure on D3S by 2 stop, and I have to reduce the exposure by 3 stop on D850 to get exact matching, sort of. So let's compare. On the left hand side we have, actually I have to reduce more. Right. Let's do by additional. Okay, let's do 2/4, 2/3/4. Okay, let's do one. Yes, D3S, D850, compare. So on the left hand side we have D3S at 6400 ISO, on the right hand side we have D850 at 6400 ISO, reduced by the exposure by almost 3 stops, and shadow recovery by 100%. So Get this. The details. D850 still retains a lot, but even this is talking about 10-11 years old technology and is still usable. In the front, these details are gone. Over here it's there. Even though I was focusing on D4S, this is where I focused and I didn't change the aperture. It's still the details on D850 is gone, but details on D3S is still there. The focus was just right over there. The tripod didn't move, the aperture didn't change, so this should tell you something, right? Same thing, no details on D850 over here. D3S, oh sorry, it still contains the details. That's the interesting finding actually I was talking about, that I was kind of surprised when I saw that, and I thought, okay, let me share with you how the metering affects the exposure. And when metering affects the exposure, this also affects at a different level, especially when you change the ISO. And when you change the ISO, the net output of the overall image quality is also changing depending on how many megapixels you have in the camera. So the lower the megapixel, the better the image is going to be. And I have showed you this example. Check this out. Without even, this is right from the camera image. Check the details. And this is D850 right from the camera, no editing. 6400 ISO D850, and this is also 6400 ISO D850 and D3S, and this D3S having a lot more details in compared to D850. And if you can, I don't know if you see this histogram is shifting towards right, like at 6400 ISO the image was bright and the camera was on aperture priority. This was at 4, almost a stop difference. Damn. So this should tell you something, that the bigger pixel on D3S was gathering so much light that the camera has to almost double the shutter speed to get the exposure equal to this D850. Amazing thing. Seriously, amazing stuff. But when you try to recover the details, this is where D850 shines, in my opinion. This is at 6400 ISO. I'm trying to recover the shadows. Look how messy this is. Now if I do the same at base ISO 6400 of D850, check this out. It's super clean, like nothing happened, because it's a BSI sensor with superior SNR firmware. This is where D850 shines. Now check this out. This is D3S at 6400 ISO. Trying to recover the shadows. I am seeing bending, but details are there, much better than D850 over here. Okay, so let's do the same at base ISO of D3S. It's super clean. So both cameras, D3S and D850, producing super clean images even when you try to recover the shadows by 100%. And when you increase the ISO, D850 was losing the details, while D3S still retains all the details. But you are going to see banding, but only at higher ISOs, not at the base ISO. D850 was not able to show you banding, but the details were missing because the SNR firmware, when you try to remove the banding, it also tried to remove the details at the same time, because the SNR firmware applying the algorithms universally over the whole image in this part. That's why you don't see banding like D3S over here. No, over here. This is. So after I do the same over here, I don't see much. So that's one of the reasons SNR firmware plays a very critical role in order to compensate all the losses that D850 was having due to the smaller pixels. This is where SNR plays a huge key role in order to compensate all those gains which D3S was having due to the bigger pixel pitch. D850 was not having those bigger pixel pitch. This is where the SNR firmware basically compensated all those things. So let me sum up everything. In when you see a lower megapixel versus, let's say this is the lower megapixel 12 megapixel D3S, and this is 46 megapixel D850. When you see these images, all you need to make sure, when you are in low light, always try to shoot with low megapixel camera, because it always contains all the details, even if you are increasing the ISO. But when it comes to recovering the dynamic range, when it comes to recovering the shadows, this is where these high megapixel machines shines over the lower megapixel, because these lower megapixel machines like D3, D3S, D700, they are like 12-year-old, 10-year-old technology, where the software was not good, the SNR firmware was not advanced. Now D850, D6, D5 or D500, these machines are very much capable to handle high ISOs, but and also provide you the better dynamic range, actually the best dynamic range, especially in case of D850, because superior SNR, the SNR firmware. So this test was not only about showing you how the metering works, like this is matrix metering, this is spot metering, matrix metering, spot metering, matrix metering, spot metering, matrix, spot. So not only that, but also gives you an insight how bigger pixel pitch still better for low light, and why these machines like D850 high megapixel are better for recovering the shadows. So imagine, now this is the interesting question. I was having a conversation with one of the fellow photographers, like, imagine you have a machine with 12 megapixel or 10 megapixel or 8 megapixel, but with the SNR like D850. Then imagine how that camera is capable of shooting in low light. Not only provide you the clean images, but the best dynamic range. Now only closest camera that we have, which not only provides the low light, like lower megapixel, which can handle low light, but also the superior SNR, was Sony A7S and Sony A7S2. That was the last camera of its generation where it contains the bigger pixel pitch camera, but with superior SNR firmware. This is why most of the astrophotographers was shooting with A7S. I'm really looking forward to see A7 S Mark III. Hopefully, I'll get it someday. Thank you very much, and I'll see you guys soon in future with some more interesting finding. Stay tuned, stay safe, and do tune our Facebook channel named View and our YouTube channel VUEGRAPHY. You have a very lovely day.